Some more absolute inequalities. We just have multi-step questions now. It's the same core concept as before. We're just add a little bit of stuff before we get to the new thing. And by new thing, I mean the thing we did yesterday. So if we look at our equation, we have 3 times absolute value -7 plus 9x minus 5 less than or equal to 97. So if you remember yesterday, and I put them up here, are 2 rules. What to do with an absolute inequality. And the key here is before we can even look at those rules, we need to isolate the absolute value. So before we do anything else, we need to get rid of everything from the left-hand side except for what's in the absolute value. So I want to get rid of this -5 and this times 3. And we do that just like we've done with equations. So to get rid of -5, we do +5. I try to write this as small as I can to preserve space. So 3 times -7 plus 9x absolute value. This cancels, less than or equal to 102. And then we want to get rid of times 3, so we divide by 3. So we have the absolute value of -7 plus 9x less than or equal to 102 divided by 3 is 34. Okay. So now we have what we had, or what am I saying? We have now what we had yesterday, which is the absolute value less than or equal to some number. Once we get there, we look at our 2 rules. Since this is a less than problem, we know it's going to be an and kind of situation. So it's going to be -c less than or equal to everything in the absolute value sign less than or equal to the positive value of what's on the right. So we're going to write this out as -34 less than or equal to, we drop the absolute value sign, so just -7 plus 9x less than or equal to +34. Okay? And now we're just trying to get x by itself. So if you want to split this into 2 separate equations, you can. Or we can do this all together. Let's actually pick blue. So we don't have too much winter break colors going on here. +7's all the way around. -34 plus 7 is -27. Less than or equal to, these will cancel. So it's just 9x less than or equal to 34 plus 7 is 41. And then our final step, we divide by 9 to everywhere. So that's going to give us -3 over here, less than or equal to, these x's will or the 9's will cancel rather, x less than or equal to 41/9. I don't know what 41/9 is. That's it's like 4.5. It's like 4.6. Okay. If you wanted to graph this, so here's -3. Here's 4.6-ish. So x has to be greater than -3 and less than or equal to 4.6. So our answer is anywhere within that range there. You don't have to graph these, but it might help you when you're thinking about the signs. Okay. A couple things to note, and we'll see that in the next example, is you still have to follow your rules for inequalities. So all these were positive, what we divided by, but if they're negative on either place, if this was negative, if this was -3, then the sign would have flipped here. Or on this last part here, if this was negative, if this 9 was negative, we would have flipped the signs at that point. Okay? So all the way through, you have to keep in mind, anytime if you multiply or divide by a negative number, you have to flip the inequality. Okay, so I did want to look at one of these for a couple different reasons. There's a whole lot going on in question number 3. Okay. So we look at it, so negative absolute value of 2x minus 4 plus 10 less than 0. Okay, so we want to get the absolute value by itself. It's nice and easy. We want to get rid of this 10, so -10 to both sides. So negative absolute value 2x minus 4 less than -10. We do want to get rid of that minus sign on the outside because we just want the absolute value. So we can consider, and it kind of looks like a couple ones, so we'll expand it out. We can say really that's times -1. So we can divide both sides by -1. And that gives us the absolute value of 2x minus 4. And this is what I was talking about. We divided by a negative here, so instead of less than, now this becomes a greater than situation. -10 divided by -1 is +10. So since it's now a greater than, our rule says it's going to be ax plus b greater than c, or ax plus b less than -c. So we're going to split this up into two separate equations. I'm going to try to fit this all in this one little box here. Wish me luck. So 2x minus 4 is going to be greater than 10, or 2x minus 4 less than -10. Okay? We're just going to solve both those. So we can do plus 4 in both equations. So this is 2x, these will cancel, it's greater than 14. Or down here, 2x is less than, -10 plus 4 is -6. Okay, and we're going to divide everything by 2. So for both sets of inequalities, we're going to divide by 2. So we're left with x is, what do we have? Greater than 7, or, that's a key word here, or x is less than -3. So that would be our answer. That's the best, most correctest possible answer we could have, is that x is greater than 7, or x, or, this is a terrible R. Let me try that again. Or x is less than -3. That's the answer we want. If that was an answer choice, you pick it and you move on with your life. Problem is, so you don't have that answer. So we have one that kind of looks like we have x is less than -3, yeah, or x is -7 greater than, not so much because the sign's backwards and the symbol's backwards. So it's not this one. And then you say, else, look at C. This compound statement, it's got x is less than -3 and x is greater than 7. Isn't that the same thing? And the answer is no. Okay, and let's explain why. So when we graph this answer that we have, that's correct. X is greater than 7 or x is less than -3. We're saying that x is some point off to the right, anything bigger than 7, or anything smaller than -3. It's one or the other, okay? With this compound statement, that's an and statement. You're saying for this to be true, x needs to be some number that is at the same time less than -3 and greater than 7. And there is no number that can be both greater than 7 and less than -3 at the same time. That's impossible. Okay, so it's very important. As soon as you get to this switch point, this point here, so much stuff written up here. Once you know what kind of problem it is, once you pick either greater than or less than up here, that's going to determine what your answer needs to look like. If it's a greater than problem, your answer is going to be x is greater than a number or x is less than a number, which means your answer choice has to match that. So when we did number 3 here, as soon as we got to this point, we can eliminate these answer choices. Okay, it cannot be that. It has to be an or question. Okay, the same is true if this had ended up being a less than a number, then we would have crossed out the other choices. Okay, and then you have to be very careful with these. They're going to try to trick you. Not all of these questions have answers. So on the Canvas version, there's an answer choice E that says none of the above. Okay. So some of them will look very close, but they'll be missing a sign. The symbol will be flipped around. So be very careful. Okay. And we'll practice more of these. It just takes time. You'll get it. Believe in you. All right. Bye.